really speaking, this talk is really about architecture and how do I scale in production. So whatever I'm discussing now, it is all I have tested in production. I have agents running in production, around 40 to 50 agents in production, and that's what I'm discussing right now. So this is the URL. If you are interested in knowing which URL where you want to get this slide from, this is a tiny URL, AIMS APIs. AIMS APIs. AIMS API, tiny URL / AIMS APIs. Now, why this talk came along? Because I was looking at from the perspective of, hey, what are the problems which people are facing from agentic view? And I found that, like, hey, we are still using microservices, we are still using bulkhead, we are still solving the same problem which we were solving before. So the problems have not So problems have not changed. They are the same problem. Child is not answering your questions. Child is saying that I want to play video game. And I'm doing the same thing with my spouse. Like I sometimes try to get a present, and that present my spouse don't need. That's another problem. We don't know what they need. That's another problem from me, at least. So agent need to be trained just like a dog, You do the dog training, agent need to be trained. And who's training that dog is important. And that is what is called as agent manager. You need to have an agent manager who's going to solve the puzzle for you. You have a dog, you're going to have like, hey, how do you pet them and how do you use them? Child is the same thing. They know a few things, but we have to teach them how to do it. So today we're going to discuss that same thing today. So this is the URL. Anybody else wants to note down, you can note down here, but that's where all the stuff is located. But really speaking, what are your biggest challenges? Like I talked to some people here, what the biggest challenge is, what should I use? How do I use any of the APIs which are coming to me? And that's the challenge which is also with me. How do I solve this problem? I'm driving a car. How many here drive a car, yeah? We used to drive a car, yes? Or we all drive a car. You drive a car, okay, you have a license? Okay, that's good. Wow, she got license. I mean, that's good. Like, it's like sometimes I have seen people driving car without license. Yeah, I drive a car. It's like I drive a car on the highway. I don't have any license. Actually, that's happened with my spouse. In India, you can get a license without going to DMV. Well, I shouldn't say that. It's recorded, but well, that was way back. It used to be done. But we don't want the same thing to happen with agents. That's the problem we are trying to solve here. So if you look at these cars, these are two cars with two different tracks. And what's happening in the traditional car, which is here? Traditional car is you're trying to do a checkout. Come in the front, yeah. Traditional car is when you're trying to, when you drive the traditional car, what happens when you drive the traditional car? Change the guest? Gears? Okay, yeah, you have to change the gear and then you drive this car. And you know what, when you're driving, you're checking out. This user is checking out. What do you say to the user? Don't click the back button. Yes, you say that? Don't click the back. If you click the back button, good luck. I told you, don't click the back button. Can you say that to this AI, which is running, brum, 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 brum? Whenever you say brum, 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 what's happening? What's happening? Cost is going up. You go and say thank you to ChatGPT. Say thank you to ChatGPT. Why did you say that to me? I had to consume so much energy to do that. Like now we say that, like, electricity bulb which is running. This is so much stuff is happening. So plan, call, observe, decide, and repeat. That's exactly the cycle which we are all going to go through. And this is where the duplicate holds are happening, retry storms are happening. And when we look at any of these agents, now I'm going to look at some of these agents right now. So what's really happening with this agent is when we are looking at it, take a look at this agent. When I am doing an observe and decide what to do is more important for me. What should I do? Should I check the limits? Can I do these things or not? Somebody is asking me to check out a $100,000 item. Should I check that out or not? Somebody is asking me to $100 item. Should I check that out or not? And then I need to plan what should I do. They always say that, like, hey, you should plan your trip. You ask Google where I'm going, where your destination is, and that's where you go. And then do the tool selection, and then you're trying to do that. Now that's where the retry is coming in. Now why the retry is coming in? Whenever you need to do a retry, what happens in terms of retry? Whenever API, we are making API call, yeah? When I make an API call, if the other API is not there, what do? I retry. But is that a good thing or a bad thing? It's a good thing if it's a human. It's not a good thing if it's a AI is there. And that's why the microservices, when you're trying to create, we have to be understanding how much budget do you have. Do you have the budget to really retry 5 times? That's where the problem is coming is. And are you supporting idempotency tools? Oh, anybody, idempotency, anybody, what is idempotency? Yeah, so you're trying to do a create. You said that I want to create an order. Huh? It can be. That's what I'm discussing right now with you. Aha. So what's really happening is, so when you're trying to work with an idempotency, so for example, when you're trying to create right now here, create an order, and when you create an order, the intent is to create this order. It's been sent to Stripe. Yes? When it is sent to Stripe, it has not processed it, but it has assumed if you ask the same data to add again, it's going to keep that idempotency key before you save it, okay? So that you have to put it in your code. If you do that, now how many here have that in your code? You guys have it for all the creates? You are asking, you have it for all the creates? One service is good. That's good. Oh, one person, one service. Okay, oh my God, like my talk is over now. That's good. Like I like it. Like the problem which I'm trying to describe, like you drive a car, you have a brakes. Do you have a handle of the brakes? Like you're going through the curve, you have a brake going on. Do you have a brake for AI? Anybody got a brake for AI? I create an agent in production. Do you control that agent? Anybody do that? No. We're going to talk about how to control the agent, like how my spouse controls me. We're going to talk about that, like how to make sure like I become more listening, and that's where like she give me some costs to work with. Hey, you have this budget, don't spend more than that, yeah. And this is the time budget given to you. Check the limits. And that is what people are missing out. People are saying that, hey, I want to just create this out. Like, I don't care how it works. And that's what happened the night everything was still broke. The broke part is that whenever we are trying to work on the AI, now what's happening is that now we are monitoring. Now, when I'm trying to monitor, whenever I make a call to database, when I make a call to database, what happens? It has a latency of P99. What is P99? Anyone? Huh? 99% of time, this API will be 400 milliseconds, yeah? And we used to say that don't worry about the remaining, and just work on this. Not anymore with AI. Because with AI, it gets amplified. So we'll talk about like, and that's where the cloud bill increases. Like cloud bill is like, oh my God, like you get like a cloud bill really increase a lot. So what we need to do is we need to protect ourselves. Like, when I'm trying to work on the solution, the launch day is there. Hours later, the next day, you have a lot of money coming in. Now, if you want to search for it, Jeff, Deans, and Lozi, it's like the tail at scale. Okay, search, write it down somewhere. The tail at scale, okay? They prove that if you want to look at the tail latency is very important. Tail latency states that make sure that you are scalable. That means you have to consider P99 latency. You cannot scale without that. That's a real problem. Now, what happens whenever there is a human traffic is going on? Human user is calling, don't click the back button, I'm done. Yes? AI is calling one time? No. AI is calling, triggers that call. In parallel, it's trying to make a checkout, check for the fraud. Or it's calling fraud agent. It's calling fraud agent. Then it's calling the update agent. Then it's calling the notification. Notification is going out. Notification is going out to the email. Fraud is being called. And then at the end, the audit is also done on that same thing. Now, if you think about it, AI, we are trying to do multiple things. Yes? Not one thing. And that is difference between this and actual solution which is given to us. Everybody with me? And what we are trying to say is, what's the role of your agent? What role the agent is playing? Based on that agent, what data it's trying to get to? And where is that data located? Very, very important. This is the most important thing. People say that, hey, I don't know where my data is. If you don't have data, you cannot work on it. Data is golden. It needs to be in a format you can actually search for it without any problem, either through retrieval augmented generation or through your database tables. Doesn't matter how do you do that, or you create a mash of both of them and solve that puzzle for yourself. Now, for that data, what kind of actions do you perform? Now, what happens? Let's take a look at service agent. You know, service agent, what is service agent doing? 80% of the companies, they're going to reduce the cost by service agent. Why? Because it's a digital employee. Digital employee who has a manager, and you want to make sure you tame it, you make sure that they perform really well. What kind of operations a service agent do? Anyone? What do they do? What do you guys think they do? Service agent. What all things service agent do? When I'm talking about a service agent, what are the actions the service agent can do? That's what my real question is. They can do account management, case management, yeah. You're either supporting the account or password reset you're trying to do, escalation you're trying to do, experience management you're trying to do, yes. So in the account management, when you're doing an account management, what kind of actions this can do? It can perform these actions: answer the questions, verify the contact, reset the secure passwords. Yes? We used to take a lot of time doing the same thing. If we have the data in our system, we can do that activity autonomously without any problem. Okay? While doing that activity, what is the most important thing we need to do? We need to know what are the jobs which I need to do. You know? Just like a small child is there, you have to train that child. These are the jobs you need to do. You know, how many here know join a company without looking at job description? Actually, I did it at one time. Maybe I made a mistake. I don't know. I was a chief architect there for some time. But my friend told me, hey, join me. I said, OK, let me join. I had no clue where I'm getting into. Well, I shouldn't say more than that. But that said, like, you know, you definitely look at, hey, what am I doing? What am I going to do there? And, you know, what kind of roles do I have? And I'm going to be trained, like, you know, onboarding. Yes, how many, you know, onboarding needs to be done? Somebody said that, hey, you know, this is what the onboarding is for us, you know. And this is a senior person looking at me saying that, oh, good luck. Good luck, this code, it took me 5 years to understand. Good luck. Go fix it. Go use AI to fix that issue. That's exactly what happens. Tell me yes or no. Yes, this is what happens. Now what we are trying to do is we are trying to take the brain out of us and making sure we can create these autonomous agents. When I create an autonomous agent, I need to find out what the customer is saying. What the heck the customer is saying? Customer is saying, can you tell me about Full Moon beach party? So I want to go to the party like Friday night, Saturday night, you know, and this is the beach. I want to go there and celebrate. Not anymore, like I used to do that. But I go there and do the beach party. But before I do that, could you please give me the email address and solve for it? How did I do that? What we normally do in that case is that we are trying to come up with reasoning. When I say reasoning, that's where the reasoning engine comes in play. So for every step of the way, can you tell me about the Mool party? At that point of time, I'm trying to reason with all my topics, all the jobs I need to do, which one does this intent fit? Make sense? So because the customer can ask for anything, now you're trying to say reasoning engine is trying to do a routing. Afterward, it's trying to do a routing for you. And now it's trying to say that, hey, this is talking about experience management. Within the experience management, now I look at the instructions of the experience management and try to find out, do I have a customer details or not? If I don't have a customer detail and I ask for the detail, and now I got the verification code is added here. Once the verification code is added, what do? Voila. Now I can answer the question like about that full party, and then we can go for party, Friday night, Saturday night, yeah? That's exactly what's happening here. So what I need to do is, I need to tell what to do. I need to tell what not to do is more important. My spouse said that, only get these 5 things, and then she repeats in the text. Actually, I can show you literally, and I still get like one more thing extra. So sometimes it happens. So the perspective is that you have an orchestration agent is there, which is trying to go to different agents. This orchestration agent is what we are talking about right now. So you need to build that intelligence. While building the intelligence, the important thing is you're going to work with the prompt template. You're going to work with the prompt template just like the way we normally do. And what do we do in the prompt template? I have a meeting with this executive. For this meeting with the executive, I have this prompt written, and this is the input for the prompt. See this here, the input for the prompt? This prompt I want to execute for this customer, edge communication. When I run that, I want to make sure that I can get from a retrieval augmented generation all the relevant data for that customer, whatever the customer is interested in, and then run any API which I need to run here. Get all the details, see it's getting all the details with the JSON format here, and then voila, I get at the end, I'm able to get something like this. Make sense? So when I did that activity, I want to make sure I ground the data, return the data from here, dynamic grounding is done, and before I send to LLM, very important, what do? Data masking. Why data masking? PII data, any PII data, social security number, don't send, don't send, I hope you don't send to, if you're doing your taxes, you might be careful about that, yeah? So that's where we are sending it out. Now there is a 0 copy retention is done. Now we're getting from the ChatGPT, we get that generation back. Now toxicity detection is there. What is toxicity detection? Did LLM send me the right things to or not? If it did not send me the right thing, we need to fix those things. Make sense? Once I get that, then I do the demasking, and then I do then I audit trail it and then use it. What does that really means? We are able to get these variables and fill the solution in this case, and this solution is being filled, and then conversation. From this conversation, I go to retrieval augmented generation, found out the answer for the credit card where the problem is, and then send it to LLM. That's exactly what we are doing here. Demasking it, send it to LLM, and then once we did that, 0 copy the data, return from that data, and then now we are getting the service reply back to the customer, and then we do the feedback loop to improve on top of it. That is, whole thing is done through the audit trail. And once we do that, one of the most important thing you can do is right now here, which is generative AI. Generative AI with human in the loop. Why human in the loop? To train. Am I doing the right thing or not? If I'm not writing an email which is the correct email, who's going to tell me? Agent manager is going to tell me. The feedback loop is going to tell me, am I moving in the right direction or not? And that is what we gain from here. So what does that really mean? It means that the new failure modes are coming in. What are the failure modes? Idempotency fail. When the idempotency fails, that means now I can have duplicate orders can be created. That's one problem. Retry storms is happening there. Cache eviction. So when I'm trying to get certain values, now if that thing is not there in the cache, where am I going to go to? Database. Yes? When I go to the database, it's going to take time to retrieve that data. And that is also a big problem which is there. Same thing is true with the database saturation. Too many database requests. What is the single point of failure now? Database. What can I do to prevent it? Cache the data. Yes, when I cache the data, then I can prevent it, or read-only. Read-only database can be added here to prevent that data. And then versioning drift. Versioning is also drift. The agent is using the old endpoint, and deprecative calls are expensive. How do I manage expensive calls for the agent? That's another problem, yes? Do you agree? That, how do we do normally, developers, how do they, hey, I have made this change. Okay, you have made this change. Okay, let me make change in my code and everything is fine, yeah? There is a conversation happening behind the scene without documentation, by the way, and we are fixing it. Everybody's happy, you know? Oh, everything is in the Jira ticket. Yes? Go figure. Like, no, that's not a good idea. So that's where the real problem is coming in. The real problem is coming in is the cost scales with complexity, not with queries per second. So whenever there is a complex query is there, contextual window is very long. That's where the number of retries are happening and your cost is increasing. If you don't have the budget, you're going to get a sticker shock. And that sticker shock is real. And what we need to do is, we need to understand how do we write a microservice. Understand how do we create polyphonic responses where now I have predictable responses coming for me. What happens if I change the version name? What do I do in that case? Invisible versioning is there. So these are the real problems which are coming in currently. So when I use with the human, what do I do with the human? On the left-hand side, I think is human. Yeah, human error. Okay, flexibility is there. I just call the person, hey, I made this change. Not really. AI error is you have to make sure you change the schema. Now, which schema am I talking about here? OpenAI 3.1. Okay, if you OpenAPI 3.1, if you follow OpenAPI 3.1, it will automatically be able to take care of these problems. Okay, so what does that mean, Rohit? It means that when I'm trying to look for deterministic responses, same shape every time, you know, that's what it is. What is deterministic? I get exactly the same value coming in every time. How can I get that? Idempotency service. When I create idempotency service, no record is created, but I send this idempotency key right here, and next time whenever the order is called, deterministically I can now make a call, process the order logic here, and then when I called it next time, I'm doing a retry, doesn't matter. Because even if I'm doing a retry, I get the same idempotency key. Within 10 minutes, I get the same response back. That means that's the same. That's what the person is really looking for. And now, because I did that, I can fix that issue and then use it. That is what we gain when we are trying to work on this solution. Make sense? Now, you may ask a question like, whenever we are trying to work on this, how do machines know what's going on? How do machine know what error codes to call? How do I call the error code? And this is called RFC 9457. RFC 9457. Machine needs to understand what happens. How do machine know? Like, I can tell a human, this is what I changed. This is the error message which is there. But if I need to have JSON format, which is for the error reporting which is there, which is following this RFC, in that case, now I get proper error messages, error handling is there. Populate the field, type, and status and other things like that. Now, do you need to write any code to do this? Anyone? Do you need to write any code to do this? We currently do that, by the way, yes? We have validation for title. It needs to be 10 characters long. How many here have that validation routes created in your APIs? Everyone, yes? But you can do the same thing through specification also. Specification AI understands and it can work with it. So that means without writing a single line of code, you can have a regular expression there saying that this is the phone number and this is the format I'm expecting. How many would like to write zero code and get that? Raise your hands. This is the way to do it. If you don't do it, your manager is saying, did you add that validation? No, you don't need to do that anymore. You do the specification. If you fill the specification well, now you are good to go. Once you are able to do that, the agent is able to support it and be able to create the error handling for you without any problem. Make sense? Now, that said, now behavior which are anti-pattern. Okay, what is an anti-pattern? Whatever, we say child wear the shoes in the right place and they don't wear it. That's where the problem is. How many here have a get method? And behind the scene, you do updating a counter. How many here do that? Probably not a good idea. Even if I do that, I make a mistake like this. But if you do this, that is not correct. Because get method is only for get method. Like, you go and get to the store and get me milk. Don't get anything else. And by the way, don't change anything else behind the scene. Get is only to get. Most likely they're going to buy it. That's what we do that. Like, sometimes that's not good. Hidden side effects for the retries. Now, whenever I'm doing a retry method, there are side effects for the retry also. Like, whenever I'm doing a retry, if there is a problem, that's going to cause a problem also for us. So these things we are trying to improve on. Hidden flags. Don't have flags. An agent does not know how to handle the flags. Yeah. So what's really I'm saying is APIsecurity.io. You guys can go there and you can download this plugin. This is a free plugin. You can try it out, which is from 42 Crunch. Okay. So what it does, I think I have it somewhere. But what it does is it does something like this. Okay. So this is the open API specification. So open API specification, when I'm trying to use this open API specification, then I can actually write a code for myself and which will actually look at, and then you can actually find out, hey, if you are trying to work on that particular solution, and then if you have not written the regular expression, see this, I have a regular expression here written. For this parameter, for this name, this is the regular expression. I only accept this. How many here would like to do that? Without writing a single line of code, it's getting done for you. And that is more important. That's what I say like is more important. Once you do that, you have now built the solution which is more appropriate solution for you to kind of start using. Okay? Now you may ask a question, this is great, Rohit, but what do you mean by Open API? Open API is a specification. Open API map is there. You can search for the map also for the Open API. So it just opens something like this. Okay, I have to do like this, yeah. So this is the Open API map is there. Now within this map, now I can go in and find out what are all the things I can do. I can write the description, I can write all the contextual variable, email, and other things like that. So these are all available for me to use. How many here are using it? If you're not using it, if you're not following the schema, it's a great way to do that. Now AI understand, digital employee understand what's happening. Why? Why I'm talking about this? Because you have new employee, new customer. Okay, Rohit, what do you mean by a customer? You have a new customer, I want to buy endorsed by Messi or no, endorsed by who? Ronaldo? Yeah? Which can arrive in 2 days. Yeah? Less than $100. Okay? So when I do this right now, what's really happening is behind the scene, the reasoning engine is running. Reasoning engine is finding out, dividing it into steps, smaller steps, and then finding out the Nike Mercurial shoes, which is there, $75 to $95, and then based on that, it's giving me exactly what to get. Make sense? So this is behind the scene. What it is doing is give me So you guys, you have to code for this. So I'm telling you, ChatGPT is going to start calling, the APIs are going to start calling through MCP this, and then it will be able to get whatever your APIs are doing. Now identify the brand for that lead, Krishna, number 1. Number 2, less than 100. So I do the filtering after that, apply these things, then I do the filtering, then I choose them, and then find out who can get me in less than 2 days. So these are Amazon, Nike, and Dick's, both can get me in 2 days. So why I'm showing you this is possible as of now, it's in production. You can start doing that. Now, this is the reference architecture. If you know this architecture, you understand the whole picture, what's going on. What's happening here is on the left-hand side, there is a supervisor. What is supervisor's role? What is supervisor really doing? Supervisor is monitoring the agent behavior. It's looking at the behavior and finding out do the right things for this agent. That is called as supervisor. Okay, this is the agent supervisor who's working. What is planner? Planner is find out what is user trying to find out. Remember I did in the ChatGPT. What did I do in ChatGPT? I went and find out, this is the planner. Planner is saying that, hey, identify the brand, number 1, number 2, number 3. It created a plan for me. Everybody with me so far? You have to code for it. That's why I'm discussing this right now. Once you do that, planner is done, then there is an executor is there where what actions to perform. Once you have performed that action, which is agent runtime, now you're trying to look at different tools. Now, what are the tools which are there? Tool gateway is there, which is trying to say that enforce these policies. Somebody is asking for a refund. Okay, somebody is asking for a refund for $2,000. Should you do it or not? If you ask Amazon if the price is less than $5, they probably do it, It's like they don't want to get into it. So there is a policy gate there. There are budgets there, which are there. Authorization is then there is a version routing is there. Oh, we'll talk about version routing. How to do version routing, we'll discuss that in a second. But really speaking, this is the gateway you're trying to create to all the APIs. Order API, create order, cancel order. Now, I'm creating here create order. Am I saying order post? Did I say order post here? No, I didn't do that order post here. So, create order can now call any other agent behind the scene to solve the puzzle for us. So that means we are trying to create one instance which can solve for whole problem. We can do one more thing. I can call create order. Then I can look at is this a fraud or not. I can also look at check the inventory, check shipment, check payment. I can do orchestration on my side. That's an anti-pattern. Everybody with me? That's an anti-pattern. Why it's an anti-pattern? Because a lot of things can go wrong in this. So I already said something not working. Let I have one orchestration agent which is going to solve for us. Okay, once we did that, now we have observatory plane is there. Observation wise, I'm looking at agent runtime, telemetry, and human KPIs and plans. That means I'm going from one agent to another agent. I have one plan with replay ID to replay the whole thing what happened. So you can actually defend what happened. So I went to the store and I saw the whole plan, and why did I bought this item? Like ice cream because I liked it, So I should be able to defend myself. So that's where the observatory comes, and then once that happens, then the next thing is safety plane. That's where the bulkhead comes in. So when I say safety plane, and we'll discuss more in detail, what is safety? Everything should have a safety, Safety means agent to human routes. When I say agent to human route, you have confidence that this is the answer. And that confidence is 85%. Go ahead, do it. You have a confidence this is 60% true. Don't do it. Okay, so that is what you have to find what your confidence level is and make that decision and then have a human in the loop to solve that puzzle for you. For example, somebody is asking for $10,000 diamond link. You can say, sorry, you can't do it. Or you can give 3DS, you can get multi-factor authentication on top of it, or have someone human in the loop to take a look whether this is a fraud or not. Yes? Cost also is very important. Rate limiting you can always do. Kill switch, and we'll talk about kill switch later if we get time, we'll discuss that. Every agent should have a kill switch. What is kill switch? That means it stopped working, So you need to have that. If you don't have it, then read-only fallback. Read-only fallback means it's only for read-only services which are available to you when you're working on it. And then you apply the saga pattern. Saga means pub sub pattern. You apply with compensation logic and event bus with job queues and outbox pattern to really support it. We'll discuss all of them a little bit later. So what we are trying to get to right now is that, do your API guarantee pagination and sorting? Do you guys guarantee pagination and sorting? Or do you change over time? So what's happening is that in this case, non-deterministic path is there. Agent starts, call the API slot. Is it available or not? Oh, is it available or not? It's available. Yes, it's available. And then I give 9 a.m. Okay? And then agent check again. It's available? No, it's not available. Oops, it gave 9:30. Is that a good thing or a bad thing? What I just did? Good thing or a bad thing, or maybe okay? Bad, yes? Yeah? So how can you fix this problem? This is a real problem. Everybody faces this problem, yes? This is a microservice problem, yeah? How do you fix this problem? Anyone? Think about it. Now, when we are trying to work on the stable sorting, stable environment, stable taxonomy, I don't want to make a change in any of these things. What can I do? I can apply a window of time. Window of time means within this time, for next 10 minutes, this is blocked. This is blocked for you. And then if you don't make a decision in 10 minutes, then I'm going to release that. So that is something you can do. And once we start doing that, now we are able to get more deterministic view. It's a non-deterministic problem. Now, API, people say, is hallucinate. What can you do to not hallucinate? Make it more deterministic, yes? So the more deterministic you can make AI, the better it is for you. The better it is for you. Like your company can say, we're going to make this much amount of money next month. Otherwise, you can't say that. So that's where the perspective come in. So CRUD is coming. This is the way we all code for, guys. Like I'm guilty also. There's nothing wrong in that. Yeah, okay, it's perfectly fine. So we start with agent. Agent is coming in, get, post, order. Okay, post order is done. And then post the inventory. Update, then check the inventory is there or not. And then I'm doing authorization and confirmation for the payment is done. And who's handling all those things? Agent. Is that a good thing? No, it's not a good thing. Sorry. So that's not a good thing. So this orchestration, anything can fail here. So what can you do to really protect yourself? The best thing is you send one request, create order right here. See this here? What you do is you improve the approach by agent sending it to the order sending to inventory, order sending to the payment. So there is some other one who is doing the orchestration, not your agent is doing it. Everybody with me? If you do that, you get more scalability. You have a controlled environment where you're working on to make this happen. And this, if you don't do this way, like, only 3 calls for the orchestration, the other one, you're making every call can fail and you need to do retry. Yes, that's a real problem which is going on. This will fix that problem, which is CRUD sprawl, which happens. Now, yes?
So in this example, the order is also another order or inventory is also another agent, right?
It's another agent, yes. It's a microservice, no? It's a microservice which is running behind the scene. It's deterministic. So we are going from non-deterministic to deterministic. So the more we can do that, the better it is for us. Because if I don't know whether I need to go for order or something else, then it's a problem. We want to go deterministic. So order is a microservice from that perspective. Now that's been said. Now another problem is separating the agent and the human traffic. Why I need to do that? Human traffic should go through human route. Agent traffic should go through agent route. How many here have the same endpoints? Raise your hands. Probably yes. Like I have the same endpoint. Forget it. So we have the same endpoint which is coming through. Now why this is true? Because there is a bulkhead policy here. What is the bulkhead policy? What is bulkhead? Huh? You are trying to shape that, anybody here saw the problem with AWS going down a few months back? The whole EC, that was last year it happened. there was a bug which happened and the whole AWS were down. I hope nobody else here from AWS, but you guys can tell more. I faced that problem because in Salesforce, we had oops, everything is down. What do I do? Watch Netflix, yeah, it works. We can do that. But bulkhead is really trying to say that, hey, route the traffic to here. Now, if the agent become rogue, what can you do? You can contain that blast radius. That's exactly what you're trying to do here. Once you contain this blast radius, now your microservice work fine, and the queues are also really doing the same thing. And once you're doing that, you're observing all these things through observatory pattern to make sure all these things are working. So that's where the bulkhead policy is really good for you to do. Now this is the API life cycle. Life cycle means what? Like, life cycle means like, you have like, we have human life cycle, start from the child and then you grow up, then you feel like you're still a child, So, so that happens sometimes. So what's happening here is like, the API is coming, see this here. So in this case, in the life cycle, I have a client identification. First thing, what am I doing here? Where do I route my traffic to? Is it an agentic client or first party client? Or is it an VIP client or a trial customer? I need to find that thing out. Based on that, I route the traffic. That's number one. Step number one, find out who the client is. If you don't know who the client is, God bless. Lot of things can go wrong. And it will happen in production, I know that. And that's where the version routing is coming. Now you're doing number two, version routing. That's where you're checking that, current version, okay, route to the current version. Deprecated version, route to deprecated version. Unknown version, route to not found version. So I have a current version is routing to the current version, and then the other routing is there. So this current version is coming in, and now because I know how to handle that, I can do the contract validation and then work on this. No issue. Deprecation, now I can go to the deprecation path and then block the request if needed and then solve the puzzle for me. This is called as API routing strategy, how we use from the API perspective. Everybody with me? Yeah? Once you do that, you're golden. Like now you're like now I gave the real power to you, like, Superman, Superman going up in the sky. So we got this power where I'm looking at agent graph. No, Rohit, why are you talking about graph? We already discussed it, by the way. Planner is trying to find out where do I go. It is creating a plan for me. What is customer really looking for? Oh, they want to go get a Ronaldo shoe in 2 days and then less than $100. That's what I said. Yes, that is done by the planner. Once that is done by the planner, now this is the parallel reads are done here in this case. Now what we are trying to do is, we are trying to authorize, create the order, and once I create the order, the carrier is there who's going to confirm this order, and authentication is there who will authenticate this order. So this is the agent graph. So if you look at this graph, what do you see? Request per second or hops per second? What do you see here? Hops per second. Yes, when I do a hop, that means I'm not doing one hop. I'm doing so many hops to get one request done. So you think about it. So you need to measure everything from the reliability perspective is hops per second. So that's very important for you to understand. Once you do that, now you're applying the workflow, checkout process. The same thing which I'm trying to do with actual problem which we have solved here. So what we are trying to do in this case, we are trying to come in and then look at the fraud handling. So what am I going to do? I need to handle the fraud, handle the timeout which is going on. So there are few things which we are trying to do here. When authorization is done, I do the fraud check. Then I do the manual retriever I try to do, and then I create the order. Once I create the order, I capture the payment right here. So that's exactly where the payments are coming from when we are trying to work on this solution. So tell me, when I'm going through the order received to these areas, this is what the checkout process normally should look like when we are working on any solution. Make sense? So why we are doing this? Because if something goes wrong, we need to do compensation action. If order failed, then what do I need to do? Void the payment authorization. Allocation failure, then issue a refund. Yes? If I can't sell the product, then I need to issue a refund. Yes? So this needs to be done in the agents when we are working on it. So that's something new which we kind of need to do to make it happen. So we already talked on this one, graphs, QPS to graphs edges. So we already talked on this one. So when we are trying to work on the graphs per second, that means we have got simple call, this is a simple call, 2 edges per run. So all the LLM is doing is, it's trying to work through edges, graphs and edges, okay? So edges per request. What am I going to ask for? How many edges per request? Complex request, 40 to 50 edges per request. So complex request is also there. And then whenever there is a request coming in, you need to put brakes on. Now, you're driving car, you need to put brakes on. What are the brakes which are there? Now, brakes are tool selection is there, observe, and then what are the brakes which I have got? I have got result contracts are these, and then we have got brakes. Retry brakes, how many times should I retry? Time budget should be there, fan out budget should be there, and cost budget should be there. Once you apply these budgets, then you can say, what is my next best action? Based on the brakes, what should I do? What should I do next? And once we do that, should I escalate to a human or not? Once I escalate to a human, now I have got on the right hand side automatic escalation. Now we have another person who are downgrading. Downgrading is done. I'm switching it to the cache mode. We talked on this, yeah? Read-only mode, cache mode you can do, or a human is trying to solve the puzzle for us. That is the whole life cycle of an API perspective when we are working on it. Make sense? Now, you may ask a question, reserve inventory budgeted, call flow. So this is a reserve inventory is there. When I want to reserve an inventory, what I'm trying to do is wait for 2 seconds and update after 2 seconds and reserve that inventory. So that inventory is only reserved for 2 seconds. Yeah. So within that, if you solve that puzzle, it's good. If you can't solve that puzzle, then you can release that inventory. So that's another part you can put in this perspective. Now that said, another problem which we all face is multi-dimensional rate limits. What is multi-dimensional rate limit means? It means that when I am trying to incoming request is coming in, identify the tenant who's calling it. It's a trial tenant. How many here using ChatGPT or some other tool? And you get throttled after some time, That's the throttle. You have to do rolling interval throttle for the user who's paying you less money. And they say that get the $200, they throttle there also. That's another problem. So what I do is I have $20, I have 2 subscription. From one, I move to another one, because the agent has to run. So I move to another one, and that's the way I'm fixing my issues. So agent limit exceed, then we need to kind of make sure that we are able to work through it. So that's the limits. So think about rate limits you're trying to apply. Okay? That's the same thing is true with the budgets also. So when I say budget, there is a budget for model tiering management. What do you mean by model tiering management? What does model tiering means? Now, if somebody is asking a question, what is your address? Do you need to send it to ChatGPT and they're going to get you back? How many here do that? I think everybody do that. We go to ChatGPT, give me my store address. They're getting it from there. And we're saying, oh, cool, ChatGPT. ChatGPT is costing money. See this here? What can you do? Very important. Cheaper model. Cheaper model means you're not paying a lot of money to that model. So that's where you want to reduce the cost by going to the cheaper model. There are ways to do that. There are small language models are there. There is a technique called quantization. You can use that. Or you can use small language models are there which can actually save you a ton of money. So that's one thing you can do. And then reliability controls. That means failed retries 3 per minute. So auto pass the agent. Don't run that agent again. That's another problem which comes in. Alert on the call can also be done. Tenant budget. You have a tenant budget alert is there. 80% you are there. So when the tenant is using it, they'll come to know, hey, I'm using a lot. I should stop using it. So that's another thing you can do. Expensive tool, you need to block that also. So we actually looked at some ways of doing these things. Another thing you can do is back pressure. What is back pressure? What is back pressure, anyone? What are we trying to do in the back pressure?
Control retries.
Huh?
Controlling the retries.
Controlling the retries, controlling how much data is coming in and how can you protect your data. Queue depth. If the queue depth goes more than 10, refuse the call which is coming in. So it will go to another, it will route the same request, will then route to another place, because you are anyways doing multi-region deployment, so it will route to another place. It's fine. So that is the way to control what's being sent out. Make sense? That's where you're kind of doing the high priority check. This is important. This is very important. You want to save money. Yeah. So when you want to save money, then you have certain processes like low value chain, low value microservice. How many here have a microservice? Anybody use Slack here? Teams here? Yeah. You guys either using Teams or Slack? Yeah. When you can see the other person is also typing at the same time. Yes. Is it so exciting? Yeah. Is that important for us to know the other person is typing and giving that answer? No, it's not important. It's important. I need to know my manager is sending me. I need to know that. But apart from that, it's not important. So what can I do? I can squash these chains and keep the high value chain. Check out. Oh, I get the money. So I want to get that. So that's what is important strategic perspective, which is there. Thunder herding the herds. Thundering herds. Thundering herds means like when I'm trying to thundering herd, is this a cache hit or not? Now thundering herd happens when I get an agent miss. Miss is going on. So whenever you're trying to work on anything. Now if you think about it, how do we do that? We know that more customers are coming to buy these shoes. What can I do if more customers are coming to buy these shoes? Inventory you need to have, yeah. But from software terms, what can I do?
Preload the cache.
Pre-warm, yes. Pre-warm the cache, yes. Pre-warm the cache we do. Auto scaling we do that. Pre-warm the cache. Can I do it here? Yes, we can do it here. That's where the pre-warm the cache is coming in. This is called a thundering herd. When you don't have to, already wants to do that, and then you have a stale while, so it will be stale while reversible. Now, it's a stale data. Is it good to have a stale data? Anyone? It is good to have a stale data. No. Why not? What's wrong in that? I have a stale data. I'm going on an airline. Airline only can carry 120 passengers, and the airline is booking and giving me the results for that, and airline is full. They do that. They have stale data. You have to find out. I agree. Like it depends, like what your use case is. But sometimes the stale data is good. Design your solution for that. Make sense? So you create an architecture where you don't need 1 a.m. call. Make sense? So I'm telling you, design for it. Design for overload. Like hey, compensation pattern. How many here love to get $500? Like it's like $1,000 app. Like okay, I can get it. Like if my spouse say yes, yeah, I can get that. Yeah. So that's what happens. So this is called a thundering herd. Once I do that, now we are able to work through agent-aware mini checklist. That means agent is aware of, identify the noisy agents. Noisy agents, noisy neighbors are there. Now, can I have a concept of noisy agents? Yes. Tenant-aware is there. Agent-aware, tenant-aware. Now, this is not tenant-aware. This is agent-aware routing. Everybody with me? So you can route through agent-aware routing. Now the traffic governance is done and finding out whether this agent is working good or bad. And then do A/B testing on agent. A/B the agent. Now this is what happened in ChatGPT. Funny thing, we will complete the play in a few minutes. ChatGPT 3 was going down. Like, they were saying, okay, we are going to destroy it now. We're going to have another one. You know what they did? It stopped working. It actually cloned itself to survive. ChatGPT 4 did the exact same thing. It cloned itself and covertly it don't want to die. That's exactly what the agent do that. So you need to be able to protect yourself from it. So basically, this is something called an airlock framework which I have created here. You want to make sure, it's a revision for you guys, agent-aware traffic. You reroute the traffic where it's coming from, and then you now try to create idempotency resilience by creating idempotency key for every post method you got. So think about all the post methods you got. Put idempotency key on that moving forward, because that's very important. Then you cache the data. Cache the data, and then because you're caching the data, you're not going to LLM. You can solve the puzzle for yourself. And then you create loosely coupled async calls and queue it first and then synchronous later on. Like Why this is important is asynchronous call is always better than synchronous call, because you can create. How can we do asynchronous call in synchronous? Anyone? Queuing it, yeah, queuing it. We can do 202. We return back 202. Thanks for your order and give the link to check the status. Yeah, so that's something we can do. And then do observability with the tracing there and provide kill switch. What does kill switch means? Like kill switch means that cost guardrails and kill switch are there to really support your microservice you're working on. Okay, so duplicates can happen. When the duplicate happen, what can you do? Dedo process can be applied. You're gonna have duplicates, like that's part of the puzzle. Like you're gonna have an API. Don't click the back button, just like that. The duplicate will be there. 6 orders are getting created. How do you stop getting 6 orders created? You need to defend yourself from that. I think we talked on this subject, so I'm going to skip that. Dedupe window. So what can you do is you can create a dedupe window. What is dedupe window? For next 30 minutes, if the same item comes from the same person, it's the same one. So we're just coming in like it's perfectly fine not to do that. And that is where you're trying to create the database as a final unique guardrail, which you can create. Unique keys, optimistic concurrency, and avoid any dupes which are getting created in the database. Okay? And then circuit breakers, we all know circuit breaker pattern, which is there. When the circuit is closed, everything is good. When the circuit is open, don't send the traffic to that place. Simple. Like we all know that. And bulkhead, this is very important. Bulkhead is created. Think about the bulkhead created. Agent is coming in and it's going to process it to premium agent, experimental agent, tenant agent B. That is the bulkhead. When you create that bulkhead, now you're adding exponential back off with tethering to really solve for the puzzle which you're kind of looking at. Make sense? Now you're trying to apply the retry logic to really able to make it happen, right? So I hope this is something which you can apply on the cycle which you are trying to work on. Basically, what you're trying to do is you want to make sure you are able to remove the bill shock which is coming in. So that's one thing which I suggest us to do in this case. Open telemetry, I think we all have seen open telemetry before. What we are trying to do is we are trying to find out all the keys from the agent. So when one agent is calling another agent, you send it to Jagger or any other tool, and now we can replay that same ID again and again. Right, so that will be useful for us to do. All right, I think that's pretty much it from my side right now. I'm here for any questions, but basically every tenant should have its own budget. Like just like my spouse say, hey, don't spend more than this amount of money. That's not with my kids. Kids carry our credit cards. We don't even tell what they're spending, and then what they're going to, where they're going to? Starbucks. I need to go to Starbucks to get something. I'm just not saying anything wrong in Starbucks, but you don't need to go to Starbucks for everything. It's like such a happening place, and you get a latte or some kind of different lattes. But what did we discuss so far? We discussed the fact that you need to plan, and then correct tool we need to get. Once you get the tool, that means you're observing. You have kill switches added. Observe what's going on, and then based on that you make a decision on top of it. So traditional is not going to work. You have to make sure you're able to act on the essential, put in the brakes to kind of make it happen. All right? So this is the link you might want to keep. Take a photo of this link. This has the top information. If you want to connect with me on LinkedIn, please do that. I'm here for any questions. Otherwise, you have a wonderful day. I'll catch with you some other place.